All right, we're about to get ready started on a pretty interesting project. A good friend of mine, Ron, is going to turn this motorcycle into a Café racer. And a big part of the plan is going to be to remove the old style fuse block that's part of this bike and implement a product called the PDM60. It's made by Row Electronics. And we'll hit on a lot of the features of the PDM60. That the intent is more to walk you through a custom wiring diagram that I've developed to allow us to utilize that PDM60 for this purpose. So stick around, this could get interesting. Alright, this is the PDM60. It's a power distribution module 60. It allows you to distribute 60 amps over any of these 6 circuits. Kind of a neat thing. It's only about the size of a credit card and less than an inch thick. And again, it's got 6 different circuits. This thing was originally marketed that you could add this to a newer style modern bike. And instead of, the newer modern bikes don't like you to tie into the existing circuits. Sometimes they'll shut those circuits down. So this product was built to be a supplementary set of circuits. You can run, basically tie directly into the battery and then run 6 brand new circuits to power things like GPSs and iPhones and that type of stuff. So what we're going to do is we're going to incorporate this and use this in complete replacement of the old fuse style, so we don't have to do that. The neat thing about this is if you trip a circuit, what happens is you can just turn the key off and turn it back on, and that circuit will reset. We can see that all circuits are turned on, and if I take one of the, I take the orange circuit and I short it out, basically we just shorted out the that circuit. Interesting thing is all you got to do is turn the bike back off, turn it back on, and it resets that circuit. So that's no more replacing broken fuses. This thing resets itself just by cycling the ignition switch. So I'm going to let Ron introduce the project a little bit, and then we'll go through a diagram.
Okay, this is my next project. This is a 1972 Honda CB500. When I bought this bike, it was just a frame and a bunch of different parts. And one of the things that I did not get with this bike was the stock wiring harness. And I also wanted to remove the old bladed fuse system that was on here anyway. And so I found this PDM60 online, and I went to Mike and I said, Mike, even though this is not necessarily what it was designed for, do you think we could make this work? And also remember that with this wiring harness, there were things that we're going to be deleting, that we're not going to be using on this bike since it's a Café racer. Like, for instance, we removed the rear turn signals and the indicator lights up front, which have the oil pressure switch, the neutral light, as well as the clutch safety switch. So Mike was able to come up with a wiring diagram that we've been using to wire this bike.
So as we got started, the very first thing we did is went out on the internet and found this original wiring diagram for this bike. How cool is that? And so we're going through this diagram, and when you first look at it, it's kind of daunting. You think, wow, this is just kind of crazy. But as you look at each individual circuit, it's pretty apparent as to how things work. And one of the things that I first really realized is it's not just going to be a easy plug and play of that PDM60, but we're going to have to kind of rewire some of this. And with that, I knew I was going to probably have to redraw it. And I actually then started kind of realizing I kind of wanted to redraw it. It was going to give me an opportunity to delete the components we weren't going to use and get rid of those wires as well, and kind of clean it up, thinking that I would have maybe half the wires. Well, that's really not the way it turned out. We still have a bunch of wires, but we do now have we'll have a custom wiring diagram that if Ron ever decides to sell the bike or something, he can give that with the bike, with the documentation, and be a great resource for the next guy who has it and can follow along. So before I go over that new diagram, I want to just do a little bit of housekeeping, just go over some terms that I'm going to use and make sure that you understand just some very simple things. I'm almost embarrassed to do it on how we're going to switch some of these circuits. Some of the circuits are positively switched, some of them are negatively switched. So let's kind of go over that. In diagram 1, there's a couple illustrations. The top one being a very simple circuit, a battery on the left, electrical components such as a light bulb on the right, almost indicating kind of like what a flashlight would look like. We have a wire going from the positive lead of the battery to the component as well as the negative lead of the battery to the component, creating a complete circuit, and in this case the light bulb would turn on. The only way to turn that light bulb off would be to disconnect the bulb or disconnect the battery, but in most cases we don't like to do that, so we put a switch. We just need to break this positive or break the negative, and we'll show some better illustrations of that on the next diagram. In the lower diagram is typically used in the automotive and motorcycle industry, where they incorporate the frame as part of the negative circuit. They actually come straight off the battery and connect that to the metal frame, the metal of the frame being an electrical conductor, and then somewhere in another location coming off the frame with that negative and then supplying the negative lead to the electrical component, that thus completing the circuit. This also would allow that light bulb to come on. It's very important to understand that the frame is used in the grounding system. In the second diagram, in the top illustration, we have an example of a positively switched circuit. Basically, we're just going to introduce a switch on this positive leg. If we open that circuit, it disconnects it, basically turns the light off. If we close the circuit, it's on. Similarly, in the negatively switched circuit, we're just moving the switch to the negative side of the circuit, and by opening that circuit, we basically also turn off the light. In diagram 3, there's a couple situations that I wanted to illustrate. First is when we have switches in series. That means switches are basically side by side. And it's kind of like an AND situation where this switch has to be closed and this switch has to be closed and this switch has to be closed in order to complete the circuit. In a typical bike, on the starter button circuit, there are typically 3 switches that are put in series. There's a neutral safety switch. If the bike is in neutral, this switch is closed. On the clutch lever, there is a switch, and if the clutch is pulled in, then this switch is closed, and then if you push the starter button, you're closing this switch. All 3 of those have to take place at the same time in order to complete the circuit, which basically enables the starter solenoid to tell the starter to start. Likewise, there's also a thing called a parallel, putting switches in parallel. We have this will be evident in the rear brake light switch circuit. On the positive leg, there'll be 2 switches. One is your handbrake switch up on the handlebars, as well as a foot brake switch. In this is an OR situation. If I pull the handbrake, it closes this circuit. That completes a completed positive leg. Therefore, the brake light will turn on. Likewise, if I just put the foot brake on, this switch will close, and it provides a path to complete the circuit. Again, the brake light will turn on. Or if I do them both, then the brake light will also come on. So we're going to have that situation in this bike as well. So let's now take a look at the new wiring diagram. To get you a little familiar with what you're looking at, this is basically a view of the bike from the top, where the area on the left is the front of the bike, the area on the right is the rear of the bike. This is the right-hand side of the bike and the left-hand side. Most of these components are drawn very close to where they reside on the bike. Another thing I want to point out is there's a gray dotted box right here, and what that represents is what's happening inside this headlight bezel. Most of your main wiring harness dumps into the bezel. It makes different connections to different pieces, and then that exits back out another wiring harness to a specific component. So keep in mind that everything in this box is actually happening inside this bezel, and everything has got its own unique connection. Also keep in mind that for this specific drawing or this diagram, Ron purchased some new hand controls. This right hand control and this left hand control, we purchased those online. They did not come with wiring diagrams. So the very first thing we had to do is to use our multimeter in continuity mode and figure out which each of those wires did and what colors wires were hooked to each of the different little switches, because most of these controls have at least 3 switches on them. And we developed this small little chart that shows those wire coloring codes, and that helped me then make sure I was connecting the correct wires to the correct circuit. Now, instead of using this diagram to walk you through each of the circuits, I'm going to turn off all of the circuit information except for the circuit that I'm wanting to describe to you. I think that'll help you understand what that is. And again, this whole video is not about running a wire and how to crimp it and that type of thing. This is more the theory of how this is implemented, because one of the things that I realized is if you know how we implemented each of these circuits, know why these things work and how they work, it's going to allow you to take this diagram and make a few minor changes to it, and that way it will be applicable for your project. So let's take a look at actually powering the PDM60 itself. This is an electrical component and it needs to be turned on. And the way we do that is it's going to be a positively switched circuit. It's got a black cable coming out of it that we will mount to the frame. That'll be its constant negative circuit. The positive circuit is going to come directly from the battery. Now I've got a wire here labeled BM, which stands for blue, and it's my main wire, so that's why I put BM. But this wire is basically connected directly to the battery. Notice it actually, I don't want to make too many connections directly to the battery, so even since this is a solid circuit here, I've actually made the connection here to the starter solenoid. But in essence, we have a direct connection to the battery, unswitched here. That blue main wire is going to run through the main wiring harness into the headlight bezel, be connected to another wire that goes out the small wiring harness to the main key switch. On the main key switch, we're going to connect that blue main wire to the existing red wire of that switch. Then that wire becomes switched to the switch. If the key is in the second position, we get continuity to the brown wire. So against this brown wire, I'm going to come out of that and convert it over to a gray wire. Take that gray wire into the headlight bezel and then out through the main harness, and it's going to feed into the gray input wire, the PDM60. That is the switched positive leg of the PDM60. When this key is in the second position, it completes the positive circuit. Therefore, this PDM60 will have both positive and negative. It will turn on. That is the key to turning on the PDM60. I want to also illustrate the other additional wires. There is a very large red wire that's going to be directly connected to the battery, and it's the signal through this red wire is what's going to be distributed over the 6 different circuits that's distributed by this device. And we're going to get to those next. So now let's take a look at the ignition system. The ignition is, there's an ignition system that's actually a rotating assembly that's attached to the motor that'll rotate with the motor, as well as the ignition coils that feed power to the spark plugs to make them spark. Basically, once this PDM60 is powered up, it's going to send a positive signal out the white wire, which is our number 1 circuit. And so over here I have a white number 1 is basically white in the number 1 circuit. That's going to feed out into the headlight bezel, come through, and then I'm going to connect that to the gray wire of this hand control. That's going to feed this center switch. And if the switch is turned in the off position, then there will be no connection. If it's turned to the on position, it will come back out what is labeled on that control as the light blue wire. So we'll bring the white blue wire back into the headlight bezel. I'm going to change that over to a white black wire, saying that it's the white circuit and black meaning it's been switched. That's going to come back out through the main harness, and it's going to feed and then get split. And I need to take that positive circuit and feed it to both coils. So part of it will come out here and feed. This will be now switched positive to the right hand coil, and it'll also go to the other side and be the switched positive for the left hand coil. That leaves this blue wire as being our negative circuit, and that blue wire will come back over to this side and into the wiring harness, then back out a small loom piece here and connect to the ignition system. And the ignition system is also basically a rotating switch as well. It's switching our negative portion of the circuit. That piece is grounded locally to the motor, and the motor is grounded to the frame, so it's got a good ground. And then as it rotates, it'll basically turn on and turn off the negative signal for both this blue wire and the yellow wire. As it's doing that, it's sending that back out. The yellow wire is going to the right hand side, the blue is going to the left hand side, and therefore we have our completed circuit. That'll actually send, when it momentarily connects the negative, that's when you'll get a pulse out the spark plugs. So that completes the ignition system wiring. Next we have the brake system. We mentioned this earlier in the video. The brake system is a couple switches that are in parallel, And this is again a positively switched circuit. Coming out circuit number 2, which is our purple wire, we'll get a positive feed coming out the purple wire, and that purple wire will feed both to one side of the rear brake switch, as well as it'll be split and come across, and it'll feed one side of the handbrake switch. If the handbrake lever is pulled, it'll close that circuit. It'll send out this purple black wire into the headlight bezel, and that'll be carried on all the way through and basically force the this light to turn on, because it's going to have a constant ground that is coming and grounded to the same grounding point. Likewise, again, this purple wire is a positive signal. It's switched here. Normally this is a normal open switch. If you push the rear brake lever down, it closes that switch, and it allows that signal to continue through this purple black wire, which connects to this junction and gets carried out, and also will turn on the rear brake light. So that's this green, and this purple black is how the brake, the bright element of this bulb is turned on. This is a dual element bulb. We'll also talk, actually we'll do it now. This orange circuit is powering, goes straight to the smaller element in this bulb. Therefore, notice when this PDM60 turns on and signal is sent through this orange wire, this running light will come on. So when the bike is on, you're going to have a running light constantly on, because this orange is constantly with positive and the green is constantly a negative circuit. So that bulb will be on for running lights. All right, so now let's talk about the headlight. Circuit 3 is our yellow wire coming out of the PDM60. That'll feed a positive wire out through into the headlight bezel. That's going to be split. Part of that positive feed is going to come over to the left-hand control. We're going to hook it to our dark blue and white wire, which is going to go to the little switch that basically allows you to tell it if you want low beam or high beam. If it's in low beam mode, then it'll make continuity connection with the dark blue wire and send that signal out the dark blue connection. We're going to change that over to just a blue wire and feed basically the low element, the smaller element in the headlight. If you have that switch in high beam mode, it'll send that positive signal get diverted to the other wire, which is the white wire coming off this control. We'll keep that wire as a white wire. It'll come over and it'll actually be connected to the brighter element in this bulb. So that's how this, either the bright element or the dim element of your headlight, will get its positive power through switching of one of these two. The negative piece, we're going to do something a little different on this bike. Ron wanted the capability of turning off the front headlight. And so what we're going to do is for our negative, we have our negative circuit comes from the frame, comes through here, gets to a small junction here. The negative cable goes through here and up in through our right hand controller. That negative is jumped over to this top switch, and this is just a switch that was unlabeled, so we decided to use this for our headlight and illumination light on off. And again, this is we're talking about our negative side of the circuit. If this switch is in the open position, obviously we don't have a good ground, those lights are off. If the switch is in on position, then that ground will be continued through this blue-white wire of the hand control, and it'll feed into what I call a switched ground. So it'll, in the case of the front headlight, it'll provide switched ground to this front. So this headlight actually has a positive switch, just whether it's between which two elements they want lit up, plus you can turn it off by actually disabling the ground part of the circuit. Likewise, that same switch is going to be able to switch on and off the ground signal, which follows through here, and it provides the grounding for the speedo illumination as well as the tachometer illumination. Our next circuit is circuit 4. It's the red wire coming out of the PDM60. It was an extra circuit. We're not going to use it. We are going to go ahead and run that wire, red wire, up to the front into the headlight bezel, but we're not going to use that. So we'll cap this off so that it can't short out anything. But it'll be used possibly in the future for powering up a iPod or charging a cell phone or something like that. We're just not sure what we're going to do with that. We'll go ahead and wire that up to the front, so it'll be very easy to figure out what we're going to do and finish the wiring for that, and just to show that it'll also then just be able to connect into this constant ground. So that's what will end up happening with this spare, currently unused circuit. Our fifth circuit is dedicated to the starter. It is the brown circuit. So coming out of the brown, when the PDM60 is turned on, a positive signal is going to come, and it's going to basically connect directly to the starter solenoid. So this starter solenoid always has a positive signal, but we're going to switch the negative side of it. So this will be a negatively switched circuit. So let's follow that, the negative switch circuit. Coming off this grounding point, we'll go into the wiring harness. Again, this is like a shared ground. That ground will be brought into this wiring harness here. This from green is going to change over to this black. We've already seen that in the previous drawing. That black connects to this side of the push button switch. That's the starter button switch. That switch is normally in the open position. If you push the button, it closes the switch, continues your ground out the yellow-red wire. The yellow-red wire comes through that small wiring harness, and then we're going to connect that to a brown-black wire. That brown-black wire is going to continue down and come all the way down and provide basically the connection for the negative side of the starter solenoid. When you push this button, you are completing the negative circuit, giving this starter solenoid both positive and negative. And this is basically an electromagnet switch. That's going to throw a switch here, enabling basically this positive wire connection here to connect across jumper this and finish this positive lead to the starter motor, which is grounded locally. The starter will then start. So that completes the starter solenoid switch circuit. Next, let's talk about the alternator, or what they call on a motorcycle, called a stator. That is your charging system. That's what's going to recharge your battery. And basically they have on a typical bike, they're going to have a thing called a rectifier, and they're going to have a different item called a regulator. Ron has found basically a solid state unit that does basically both the rectifying and the regulating, and so we're going to implement that. Interesting, we'll be able to use the existing harness that goes between the typical rectifier regulator and the stator. We're going to just key into that, basically plug this item in. It'll plug in just directly like the directions say for it. We're not going to do anything special for that. We will provide this circuit. We'll provide it a constant ground, so the items will be grounded, as well as it'll get its a positive signal directly from this brown circuit as well, and that connects to a black wire that's right there. And in essence, what's going to happen is as it's charging out of this red-white wire, the red-white wire will be connected back to this side of the starter solenoid, which basically is directly connecting it to the battery. Again, you don't want to have too many connections directly to the positive side of the battery, so we've spliced into it here. It's basically the same thing. And now for the final circuit. This is for the front blinkers, left and right, as well as the rear running light. The rear running light I covered when I covered the rear brake light. The front blinkers is a positively switched circuit, so we have a constant negative coming off this grounding point, running through the harness into the bezel. That ground will be split both to the left and the right side, connecting to the black wire of our particular blinker lights. That'll be on both left and right. And then the positive side of the circuit is going to come off our sixth orange circuit, come into the main wiring harness, and then it'll go to the winker relay. It'll connect to the black wire of the winker relay. This winker relay is going to create basically a pulsed positive signal that'll exit the winker relay through the gray wire. We will connect that to our brown and red wire into the main wiring harness, forwarded to the front headlight bezel. That'll then circulate over to the input of the left hand control, and we're going to connect that positive brown red wire to the gray wire of the hand control. That'll come into the middle switch that's on the hand control, which is basically a three-way toggle switch. If that toggle switch is in the middle position, then it's just an open circuit. If that switch is moved to the left hand side, that signal will pass through this orange wire of the hand control. We're going to convert that to a dark blue wire. That wire will come through this wiring harness to the left hand blinker light and connect to the dark blue wire of that blinker light, creating a completed circuit, yet that positive signal will be pulsed and that'll provide the blinking light. If that switch is moved to the right hand position, the signal will go through this light blue wire. We'll continue that with a light blue wire through the headlight bezel over to the right hand light, connecting it to the dark blue wire of that light, providing a pulsed positive signal, giving us the blinking for that light. And that completes the circuitry for the blinkers. Let me leave you with a couple final thoughts. First of all, I hope you found this helpful. It was a very interesting project. I've really enjoyed putting it all together. The PDM60 seems to be a pretty good quality product. We're pretty pleased with it so far. As far as these diagrams, I'm going to make links down below this video that you can download those diagrams for free. The first link will be to a one-page PDF that you should be able to download pretty easily and print to your own printer. And it'll be the one page that has all the circuits outlined on it. The second link is going to be to an 8-page PDF where each of the individual circuits are highlighted. When I mentioned to Ron that I was going to put that together, to put this video together, he said that he wanted to print out of that because I was really going to help him do the installation. So you might find the same thing. So those are the first two links. The next link is going to be a link to a forum where Ron is documenting this build of this bike called Logan's Reward. You might want to follow that link and follow his progress. And then the final link is a link to the first bike that he restored with his son. It was a senior project, and they put that together, and it was called Stella. So you might want to also follow along that progress there. Anyway, hope that, again, that you found this useful, and good luck with your project.